All right. Long time. We're back with the mathematics. So we have a question which is talking about identifying the conic that we have. So here is a question that we need to look at in order to identify the conic which we have. So here we go. The question is as follows. So this is our question. Then we have been told to identify what type of conic we have. So we can do this in two ways. There is a way of directly going for completing of the square, because we do not have we do not have b. When I say b, I mean that component which has x and y together. We can't go for a specific way. There is an option here. We can go by the degenerate equation, which is a x squared plus bxy plus cy squared plus dx plus ey plus f equals 0. But in our case, we do not have the b part. The b part is the one which refuses us or denies us the access to go for completion of the square. But in our case, it's an open question. The question just said, identify the conic. So we have, whether we replace, I think it will just be the same as completing the square. But to be specifically fit for the exam and no changing of order of operation, we can just go for the one we have learned, which is about the rotation of axes. So we can see there is y there and there is x, and we do not need to work with them, but we need to work with the primes. The primes are the ones that we have to work with. Okay, so for our degenerate equations, we need to replace x with, if you can remember, x implies x prime cos theta minus y prime sine theta. And then the y part deals with x prime sine theta plus y prime cos theta. That is our case. Hopefully this one is clear. I know you're preparing for the exam, so I need to give you as simplified work as possible, but which is quality for the exam. All right, so after dealing with this, we can see sine theta and cos theta there. So our aim now is to get rid of the sine and the cos. So how do we get rid of those? We first need to identify the equation of tan 2 theta equals b over a minus c. So we need to identify that equation. Then from there, we need to know what theta is so that we can replace it in terms of the sign there. So now, what is this? We are going to go back to our question and then write our degenerate equation, which is ax squared plus bxy plus cy squared plus dy plus dx plus ey plus f equals 0. Then let's identify what is needed for the equation for us to find the theta. We need a, we need b, we need c. So what is our a? So we look at this equation and then compare with our equation there. So if we see a and a there, so we can see that a is 4, and then b, we see we need a part which is having xy, but in our equation there is no such a part, so we need a 0 as our b now. C is a part getting y squared. What number is getting y squared? It's 9. So that is the case now. So now I have a simplified way of since you're going for the exam, you don't need a lot of mastering or a lot of remembering of concepts. I know it's you have a lot of work. So to make this work easier, as long as, so this is the point now, as long as if b equals 0, then theta also 0. That's what I want you to remember. So that's the concept. If b is 0, then theta is also 0. So let's now go for the same, using the same concept. As long as b is 0, then theta is automatically 0. Hopefully that one is clear. So now replacing, let's now target elimination of sine and cos. So we shall say, what is sine 0? Since theta is 0, so we have replaced there. Sine 0 is always 0. Cos 0 is always 1. So now let's look at what are we going to replace on the x part. X equals x prime cos theta, but cos theta is now cos 0, which is 1. Minus y prime, then sine theta. Sine theta is a 0. So I've just used this top part, which is x equals x prime. Then here it is cos theta, but I know it's cos 0. What is cos 0? 1. That's why I've put this. Instead of cos theta, I've put a 1. Minus y prime. 1 y prime sine theta. What is sine theta? It's sine 0 in our case, which is a 0. So to simplify this, I mean sine has been gotten rid of as well as cos. So x equals x prime. What is x prime? It is just x prime times 1 x prime. Then anything times 0. So that is the case there. Then for y, if we come to y, it is x prime. Then sine theta, in our case, it's a 0. Plus y prime cos, there we put 1. So y equals, this is a 0. So in our case, for replacements, if it is x, we'll just put x prime. If it is y, we'll just put y prime. So that is our case there. Okay, let's go to the next page so that we can deal with this question nicely. Okay, so now let's do the replacements. So we have 4, there was x, we put x prime squared minus 48 x prime plus 9y, like that. So that is what we have. So that is our case there. So now, what have I done? Where there was y, I've put y prime. Where there was x, I've put x prime. Hopefully that one is clear. So now, let's break this question down. So as you can see, as I said, we can just use the method which we call completing of the square. Completing of the square is the method that we are going to use. Okay, let me lower the tone so that I'm sure my student doesn't like a lot of noise. Okay, let's identify the x part, the y part, and then the constant goes the other side. Okay, that's what we have there. So now, having that, we can now factorize in pairs, x part and y part separately, but within the same equation. Sweet mathematics. That is the sweet part of mathematics. They are separate, but they are together. So now, if we consider the x part, we can see a 4 there, and 4 can go there. Good. If we see the y part, we can see a 9 and a 72. These guys, they know each other. these guys, they know each other. That's one concept you should always remember, that we can factorize there. So we begin our factorization. 4 outside, we shall remain with this, minus, how many 4s are in 48? It's always a 12. Then we go for 9. How many 9s are in 72? It's always an 8. They'll say an 8. I don't know. Okay, that's what we have. That's what we have. That's what we have. Concept taken. I'm sure concept has been taken there. Okay, let's break it down. These 4 stands, but inside we need to simplify again. Completing of the square will be done. This is squared, don't forget. This is squared. The y is also squared. The x is not squared. The y is not squared. So now, this is what we do. We target the number which is going to be here with the x which is not squared. What number is here? 12. So we have got -12. Divide it by 2. We're going to get -6. And then square that number. That's what I've done there. I've targeted the number which is attached to x which is not squared. I've divided by 2. Thereafter, I've squared it. Simple. I do the same in the other bracket. I target the number which is attached to y. I divide it by 2. It gives me 4. Then that number, I square it. That answer now, I square it. So I've seen what I've done. Good. So now, it will be 4. Then inside now, we don't write squared, the x part. We just write it alone with a prime, then get the sign which was there, and then now get the answer which we got after dividing, and then square the outside. That's what we do there. We do the same to the other part. We don't get the squared, but we just get the prime, and then get the number you got after dividing, and then now square the entire part. So that's how the bracket is coming out. Then to the other side now. Be very, very attentive to this part. You have seen this one. It is coming from the first part. So this is where it is coming from. So I can just put K1 there and the K2 there, so that you know that this one is coming from the first part and this one is coming from the second part. So now what you do? The one coming from the first part, multiply it by the first number outside, but always add this side. So it will be 4, and then multiply this square by, like that, plus this second part is coming from a 9. It is coming with a 9. So the answer you got after dividing was a 4, and then you squared it. So now this squared part, multiply it by the coefficient, the overall coefficient. So it is 9, and then the squared part was a 4. So that is what we do there. That's what we do. This is what we call completing of the square. This is the completing of the what? Of the square. So now let's simplify this side. So this side we just become lazy, but it's not laziness, it's being tactical. We maintain plus 9 all right. No calculator. This is mathematics that we do not use what? Calculators. This is mathematics which we don't use what? Calculators. So what do we do? Work it out separately. Work it out separately. And then after you have worked it out separately, you will find that this is 252. This guy is 36 times 4. 36 times 4, we know it's 144. Plus, this is 16 times 9. Again, it's 144. No calculator. Please, please. No matter the case, no calculator. No calculator. If you combine these two, we can see clearly that this is going to be 288. Then we combine with a 52, and we are expected to have final answer of 36. So that is what we are expected to have there. Hopefully it is clear. Hopefully it's clear. Then now, if you look at this question, you need to have ideas already. So if you look at it clearly, it is showing us that we have got the x part, and x is a coordinate, and we have the y part. They are squared. So we need to be very tactical. This question comes in the exam. It requires you to already have the entire knowledge on conics. So it's not a question whereby it is coming so that you learn it. No. It's been treated as a question that is coming after several practices and preparations for the exam. So you really need to be there, very ready and tactical. So if you look at it clearly, it is coming from the ellipse, the standard equation for the ellipse. So this is the one, and it's a type of ellipse where the center is not at the origin, or it's not at 0,0, but has been moved somewhere. So now, what is the identity of the ellipse? It is always the case that this side where there is a 36, there should be always a 1. John said here, you need to have a 1 there. Every time you need to have a 1. So how do you formulate a 1 when you have got a number? You always divide by the number what itself. So now let's do that. Let's do that. So 36 into 36, 1. Then here when you come, just divide the number outside. So it will be 9 over 36. And then you maintain what was there. Even here you maintain only this number. So that's how the 36 has come. I've divided 36 there, 36 there, 36 there. This is the answer. But you maintain what was inside, as always. From there, I suggest we use a new page so that we can follow up clearly. So, using the odd information there was 4 over 36. If you simplify that, it will give you 1 over 9. Then there will be this, plus it will be 1 over 4. So that's the result we're expected to have. As you know me always, too much tactics, too much. So what we are going to do now, when you have a number 1 over 9 or a over b, and you want to take it down, okay, we know in the ellipse, the standard equation for the ellipse looks like this. We know it. So you have seen the way it is looking like. So that is the standard equation for the ellipse. So now it means that there is no number here, but down and the 1 always. That is the way. Always numbers should be down and squared, not on top there. And then there should always be a 1 this side. So what do we do? What we are going to do now, this number, just swap them. So this one, the inside job is done already. So here it was 1 over 9, it will be the opposite. 9 over 1, which is just 9. Plus here it's 1 over 4, which is going to be 4 over 1, which is just 4. Which is just what? 4. But that's not how it goes. It goes with a square? A square. So now, find the square roots of these numbers and then square that square root. Tactical. We need tactics. That's how we survive. Square root is 3 and then square it. Square root of 4 is 2 and then you square it. And then now, the question was identified. Do not forget your question, no matter the case, no matter how you want to finish it, no matter how smart you become on that day. Please don't forget the question. What was the question? Identify the conic. So what do you say? This conic is an ellipse because it resembles the standard equation of an ellipse. Tactical. This conic is an ellipse because its equation resembles that of the standard form, of an ellipse. This conic is an ellipse because its equation resembles that of the standard form of an ellipse. So that is why this equation is an ellipse. So which question were we given? We were given this question here. As you can see, we were given 4x squared minus 48x plus 9y squared plus 72 plus 72y plus 252 equals 0. And that's what we did. That's what we did. Okay, we have another question which is similar to this one. Let's not take much time on this one. So let's just go straight to the question which is similar to this one. Okay, so the question that we have is, the question that we have is 16x squared minus 96x plus 9y squared minus 18y plus 9 equals 0. That is the question which we have there. That is our question. So now, this question and the previous question are the same. Okay, we can't say same because they are different numbers, but the way we did that one is how we do this one. Just the way we started. We can see there is no bx. There is no b which takes xy. So we have at least some ideas. It's not the first time we are taking the question. So I expect you, when you enter that examination, I know you've got a lot of data, you've got a lot of things you've gone through, but such questions should be handled with care. So step 1 to this question. So in the exam, you cannot have like this question, 2 of them, no. So the way you treated that one is how you treat this one. Do not treat it as if you are rewriting it. You treat it as if it is the first time. But in our case, we will deliberately ignore some steps because we are aware of what we are doing. So now, if you can't see b, we said b equals 0. If you can't see it, whatever coefficient you cannot see, it's always 0. Are you able to see x and y together? No. Good. Why? It's not present. Alright, so what does that mean? Your b is 0. So when b is 0, what does it mean? It means that your theta is also what? 0. Then if your theta is 0, it means that your sine will be 0, your cos will be what? Will be 1. In such a case, it also applies that you're going to have x be replaced by x prime directly, and y be replaced by what? Y prime directly. I will repeat myself. If you look at that question, it does not have x and y together. What does that tell you? It tells you that b is equal to 0. If b is 0, theta is also what? 0. If theta is 0, cos is going to be, cos will produce a 1, and sine will produce a 0. If that happens, it means that your x will be replaced by x prime, and your y will be replaced by what? Y prime. That is the tactic. That is a concept that you need to have as you go to the exam. If you can't see B, it is 0. If you say B is 0, it means theta is also 0. If theta is 0, it means cos will be replaced by 1 and sine will be replaced by 0. If that happens, it also means that x will be replaced by what? X prime. And y will be replaced by y prime. As simple as that. So in our question which have been given here, we are going to replace where there is x with x prime and where there is y with y prime. And what do? Thereafter, you use the completing of the square method. Are we getting the point? Good. So let's do that. So 16x prime squared minus 96x prime plus 9y prime squared minus 18y prime. We take it in advance because we know what we are doing. When you know, you know. You don't need to waste time. Hopefully, that point is clear to you. So that's how we're going to proceed with such a question. At this point now, we are going to factorize in pairs, just like we did the previous question. We factorize in pairs, x part, y part, but in the same question. What do? Identify the x part. So these questions will be given in such a way that it can go on the x part and on the other one. This one can go there and on the other one. That's how they come. If they come in a different manner, we can handle them. So if you've got such a question, you can just bring it on and we're going to look at that. All right, at the moment we begin. 16 factored out. So now there's a question here. 16 is there. So how many 16s are in 96? You need to start trying out. So you need to train your brain without a calculator. So if we divide 16 into 96, 16 and 16, they give you 32. 32s in 96, there are 3 of them. And then 16 in 32, it is 2. So 2 times 3. That gives you now a 6. Here it's 9. So that's what we have for a start. So just like we did, let's target the numbers in this number and this number. So as we said, we name it part 1. So it is 6 divided by 2, which is 33. Then we square it. Then we go to the part 2. Negative 2 divided by 2. Always we divide by 2. Always. You don't say. So that's the case. From there, we said we now use these numbers. No squares inside, and we now use these numbers. No squares, but use these numbers. These numbers. Sorry if I'm scaring you. Just want you to pass. Don't be afraid of my voice. Today for a few pass, so that because if you won't say during graduation. Okay. So this is the way. So after doing this, you just simplify this part. We simplify this part. You maintain for a while. It's meant for a while. So if you look at that, this is 9. We'll maintain. 9 times this is 9. 9 times 16. How many 9s are in 16? Oh, sorry. 16 comes 9 times. That's 144. 144, like in the previous question, it was 144. Plus, this is just 9 on its own. So this 9 and this 9, we are going to eliminate each other. So now we are going to have 16. So this is what we have. Okay, if you look at this question and the previous question, they're just similar. As long as there's a plus here. Oh, sorry. From here, we forgot a squared, there squared, and here squared. Okay, as long as there's a plus here, and you see such a setup, x minus inside the squared, y minus e, or plus, doesn't matter. Whatever is here. I guess in our question we had minus, yeah. So this is just an ellipse. So just aim for the standard form of an ellipse. If there is a minus, it's going to be hyperbola. That's how they are different. Ellipse and the hyperbola, they are just different here. So that's our case. So from here, I suggest you divide throughout. So when you divide a number by itself, it always gives you 1. Like in the previous question, it would be 9 over 144 plus 16 over 144. Just be careful. You know, mistakes hurt when they cost you. Just be careful. Take care. Whatever you do there, you just take care. So this is going to give you 16. You can see 16 was multiplied by 9 to give you 144. So I think it can tell you at 1 over 9 there. So these things, when you solve too much or you solve frequently, you'll be able to tell. Same case, you see? 9 there, it's 1. Then down to be 16. When you practice maths without a calculator for a long time, you'll be able to tell. I'm saying without a calculator, not with a calculator, without. Because they're already in your brain. If you're using a calculator, they're in a calculator. Alright, that aside, let's proceed to our question. So now, okay, before I eliminate this page, this is the 1 over 9. As we said, we just reciprocate. It will be 9 over 1 down. Then it will be 16 down. So if it's 1 over 9, it will just be 9 below. 16 over. What are we doing? We want to eliminate the fraction and have a number down. The standard form, we remember, there should be nothing here, but this entire thing on top over a number. So what's our idea? Just swapping whatever is here. I need you to give me a question which is going to have maybe 2 over 3 here, so that you see how we do it. My ones are simple. You just get the number down and put it down. The number down and put it down. So I need such a question. I don't want to give you. I want you to give me so that it shows that you are looking for questions. Okay, so that's what we have. So after having this, remember what we said. Find the square roots. Find the square root and then square it. Find the square root and then square it. So I'm just going for the question what I've been told. What is this conic? This conic is an ellipse because its equation resembles the standard form of a conic, of an ellipse. That's a way we eliminate this. This conic is an ellipse because it's it's without a apostrophe. Its equation resembles that of a standard equation of an ellipse. I won't encourage you on anything on how to do this, but on how to write it. I know there's a shortcut of writing it, but I just want standard things whereby no one can eliminate any mark from you. I can see there was 20 marks for each question. 20 marks for each question. So meaning you have got now 40 marks because we have done 2 of these questions. So just do better in understanding. Yeah, I know I've done it in the manner that you really needed it to be done. So all the best, all the best, all the best.